Hello students, welcome back to today's class on integers, and today we're going to discuss the properties of integers, and in that this is lecture number 2. In the previous lecture in properties of integers we discussed a couple of properties, closure and commutative, and in today's lecture we'll try to discuss about associative and then few other properties and some applications based on all this. Right, my name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So, the first one we are going to discuss today is all about associative property. For closure and commutative property, please refer to the lecture number 1 of the same properties of integers. Extension for that we are going to discuss about associative and other properties. So, what is this associative property? Till now, whatever the properties we have discussed are with the two numbers A and B, correct? So now, let's discuss about the three numbers. Let us extend that to three numbers. So, if we have three numbers and we are trying to add or subtract or multiply or divide in different patterns, let's see if those properties can satisfy equal relations. Equal means both sides it should be equal. For example, when we are talking about addition, in associative property, we are taking three numbers A, B, C. And what we are taking here? We are trying to add first two numbers, and to that resulting sum, we are adding the third one. And in the other case, add second and third, and to that resulting, add the first. Okay. So let us try to confirm whether these two are equal. In the normal numbers, we know they are equal. You can add in any way, but we'll try to discuss in respect of integers. With respect to integers means again we'll be having positive and negative numbers, so we should be very careful in that. So let us take few examples. So let me take like this: 6 plus 30 plus 5 and 6 plus 30 plus 5. Straightforward positive numbers. All are positive numbers. Okay. 6 plus 30 is 36. 36 plus 5 is 41. 36 plus 5 is 41. 30 plus 5 is again 35, and 6 plus 35 is 41, right? So, 41 is equal to 41. So, what I can say, when we are talking about positive numbers, all the positive numbers, yes, it is valid. Okay. But let us not try to conclude with this one. Let us also try to take some negative values. But whatever it is, from this I can say that, yes, associative property is valid with addition, right? They have associative property relation under addition. But let us not fix it for now. Let us take one more question. Let us try to discuss about that. So, what is the next question? Minus 9 plus 11 plus minus 4 and minus 9 plus 11 minus 4. 11 plus minus 4. So, the thing is, first we will try to add these two. Whenever you have brackets, okay, that means that they should be calculated first. That's a group. Only after that you need to go out. Okay. So, minus 9 plus 11, 11 minus 2 is 11 minus 9 is 2. 2 plus minus 4, okay, 2 plus minus 4 is nothing but 2 minus 4. Plus into minus, positive and negative will give you negative. So, 2 minus 4 is minus 2. 2 minus 4 is minus 2, correct? What about this one? 11 minus 4. First of all, let us try to discuss about 11 minus 4. How much is 11 minus 4? 7. 11 minus 4 is 7. So, what we are getting? Minus 9 plus 7. So, what is minus 9 plus 7? It is minus 2. So, are these two same? Yes, these two are equal. So, the numbers may be positive or may be negative. All the integers, numbers can be 0 as well. So, for all these, I can say that this property is satisfied. This property is valid. A plus B plus C and A plus B plus C. Add first two and then add the third one. First add the last two and then add the first one. However you add. In addition, the order is not important. It may be natural numbers, whole numbers, integers or rational numbers. Later we will discuss about that. But in addition, no order is required. You can add in any way. You will get the same answer at the last. Right? So finally we can say that integers are associative under addition. They are associative. Associative means that relation is valid. A plus B plus C is equal to A plus B plus C. Right? Okay. So let us try to discuss the same property with negative. That means with minus, subtraction. And let us try to see if that associative property is valid or not. Okay, so the first one we're having here, a minus b minus c and a minus b minus c. What are we going to do here? We have three numbers a, b, c. We are trying to find the difference of one another. So first we'll try to find a minus b, and then we'll try to find the difference with c, or find b minus c and find the difference with a. So the point is whether these two will be equal or not, that we need to verify. So what is that we can say? Let me try to take the same example with all the negatives. Okay. So minus 9 minus 11 will give you minus 20. Minus 9 minus 11 will give you minus 20, and this minus 2. Minus 20 minus 2 will give you minus 22. Minus 20 minus 2 will give you minus 22. What about this one? 11 minus 2. 11 minus 2 is 9. Okay. Minus 9 minus 11 minus 2 is 9. So minus 9 minus 9 becomes minus 18. So now tell me, are these two equal? Are these two equal? No. Why are we getting this difference? Why are these two numbers not the same? Because we have a property, negative into negative is a positive. Negative into negative is positive. So here you can see all these are negatives. That's okay. Minus 9, minus 11, minus 2, we got minus 22. But here, minus 9 is correct, minus 11 is correct, but minus of minus 2 will give you plus 2. Minus of minus 2 will give you plus 2, and that is the difference. That is the value. That is the way we are getting minus 22 here and minus 18 here. So we can say that these two are not the same. These two are not the same. A minus b minus c and a minus b minus c. These two are not the same, right? So we can say that integers are not associated under subtraction. Integers are not associated under subtraction. Okay, so you should be very careful. These are not. Okay, so I can say that these two are not equal. A minus b minus c and a minus b minus c, these two are not the same. Okay, so it is confirmed. For subtraction it is not valid. Let us try to see for multiplication and then for division. So the same multiplication also, a into b into c and a into b into c. Let us try to apply that. Okay, so for multiplication let us try to find the product of a and b and then with c, or product of b and c and then with a. Right? So let me take small question. Okay, so minus 9 into 11. 11 nines are 99. We have a negative. So minus 99 into minus 2. Minus 99 into minus 2 is equal to, okay, minus 9 into 11 into minus 2. The first one is 11 into minus 2. 11 2s are 22 with negative. Minus 22. Now, 99 into 2. What is 99 into 2? 99, 9 2s are 18, 9 2s are 18, 119. Okay, so 198, correct? 99 into 2 is 198. So negative into negative is again positive. Negative into negative is positive. So it becomes a plus 198. Plus 198. And this one, 22 into 9. 22 into 9. 9 2s are 18. 9 2s are 18 and 19. Yes. So this is also equal to 198. With negative into negative is again positive. So these two are equal. Not only this one, you can take any numbers, positive, negative, zeros, every number, every integer. So in associative property, multiplication is valid. That means that relation is correct. It is true. We can multiply in any order. Not only in integers, say when you take natural numbers, when you take whole numbers, when you take zero as well, when you take positive, negative, whatever the numbers, multiplication, you can multiply in any order, you will get the same answer at the end. You can multiply in any order, just like the addition. You can add in any order, right? But not subtraction. So what I can conclude here, integers are associative under multiplication. Okay, so that means associative properties are valid for integers. Integers are obeying the property of associative, right? So addition, yes. Subtraction, no. Multiplication, yes. Now let us discuss about division. Same way like this, A divided by B divided by C and A divided by B divided by C, right? So let us try to look into that. So A divided by B, first we need to find the quotient of this one, and with that you need to divide with C. First find B divided by C with that value, A divided by that value, and we need to find whether these two are equal or not. So let me take small question. Minus 12 divided by 3. 12 by 3 is 4, correct? 12 by 3 is 4. So 4 and we have a negative minus 4 divided by 2. Minus 4 divided by 2 will give you minus 2 as the answer. Let us check that here. Minus 12 divided by, this is a 3 by 2. Minus 12 divided by 3 by 2. So what we can conclude? This is equal to minus 12 into this 3 by 2 becomes the reciprocal. I told you many times, if we have a fraction in the denominator, that we need to reciprocate. 2 will come numerator, 3 will go to denominator. So 3 ones and 3 6, 3 fours. So this is minus 8. Minus 2 and minus 8, we can see clearly that these two are not equal. And you may ask me one question. Sir, you took some values, it's not satisfied, but I will take another values, A, B, C, such that this is valid. Okay, you can take. You can take, but once for one set of number, if it is not valid, it is not valid throughout. If it is true, it should be true for every case. It should not be like true for specific cases. It should not be false for specific numbers, right? No. If it is true for all. But here you can see that it is not valid. So it is enough to judge or to give the statement that it is not associative. Okay. Integers are not associative under division. Integers are not associative under division, right? So let us try to keep all these 4 at once in associative. Let us try to keep all these 4. Addition we discussed. Yes, it is correct. It is being satisfied. The relation is satisfied. Multiplication correct. Subtraction no, and division also no. These two are not satisfying associative property. And these type of differences will come when you have negative and negative positive in the case of subtraction. And here, when you're dividing the fraction of fraction, so all these are things which will not be satisfied with integers, right? Not only with integers, with any numbers, these two associative property will not be satisfied, right? So let's move forward. Okay, integers are associated under addition and multiplication. For addition and multiplication is correct, but not under subtraction and division. Correct? Right. So let us try to discuss some more properties. The next one we're going to discuss is additive identity. Identity, what do you mean by identity? Simple, let us say your ID card, identity card. What it resembles? It resembles you, right? My ID card resembles myself, my photo and my details. That means if I see ID card, it's about me. My ID card is mine. If you see in the mirror, your identity will be there, right? Identity means the same person. The same number should come again. Correct? The same thing, same. So, if we take a number and if we are additive, that means if we are adding, let me take one number 5, okay, and I want to add some number such that I should again get the same number back, same identity. I should get the same number back, right? So what I can say here, 0 is the additive identity. Why? You know that 5 plus 0 is equal to 5, correct? Even it is also equal to 0 plus 5. It is a positive number, so you may ask me with negative numbers. Yes, minus 2 plus 0 is equal to minus 2. It is equal to 0 plus 2. So, 0 plus minus 2. 0 plus minus 2. So what I can say here, 0 is that number when we add to the given number, we get the same number back. We get the same identity. Identity means the same number appearing again. The same number appearing again. So you can see here, okay, any number, even if you take 0 also, for 0 also, additive identity is 0. So always 0 is the additive identity. Additive identity. 4 plus 0, 4. Minus 4 plus 0, minus 4. Minus 100 plus 0, minus 1000, minus 1 lakh. Whatever number it is, when you add 0, you get the same answer. 0 is nothing, right? 0 has no value. It's not, we cannot say 0 mangoes are there in my basket. That means no basket, no apples, no mangoes, correct? 0 means nothing. So when what you're adding nothing to the number, you will get the same number again. For the number 5, you're adding nothing. So the same number will appear. For minus 1000, you're adding 0. That means you're not changing anything. Same minus 1000 will come. Okay. So that is about additive identity. In the same way, we have additive inverse. You can see here, additive inverse. What will happen with inverse? Inverse means the complete value should change. The complete positive should become negative, so that these two will sum up to give you 0. Okay, see here. For the number A, if you add minus A, okay, additive, you're adding some numbers such that you should get 0. You should get 0. For the number 4, I need to add minus 4 to get the answer 0. 2 minus 2 is 0. 10 minus 10 is 0. Minus 1 lakh plus 1 lakh will give you 0. So that means the negative of the number. The negative of the number is called additive inverse. For a number A, minus A is the additive inverse. For the number minus A is the additive inverse. Understand? If I have 10 minus 10, if I have 20 minus 20, if I have minus 1000, 1000. So these two will sum up to give you 0. A plus some value minus A will give you 0. Right? 20 for number 25, you can say minus 25 is the additive inverse, not identity. Inverse means you should get the sum as 0. You should get the sum as 0, right? So for example, 30 plus 0 is 30. Minus 300 plus 0 is plus 300, right? Minus 300 plus 0 is 300, or minus 300 plus 300 will give you 0. So all these are different examples for additive inverse. Simply just change the negative. If you have negative, remove it. If you don't have, keep it. Positive number, you will get negative number. Negative number, you will get positive number. Additive inverse, not identity. Identity means identity. You should get the same number back. You should not get 0. Inverse means for a positive, you should get negative. For a negative, you should get the positive. Right? That is about additive inverse and additive identity. Next, we will go forward to learn what is a multiplicative identity. The name itself says that. Identity means I said you that we should get the same number back. But in the previous case, it is additive identity where we are adding the number. Here we are multiplying the number. So for a number 10, let us say which number I should multiply. Which number I should multiply so that I can get the same number back, same identity back. Same identity back. So what I can say, for the number 10, I need to multiply with 1. I need to multiply with 1. 10 into 1 is 10. 10 into 1 is 10. 10 into 1 is 10. Only 1, right? You can see here. 1 is a multiplicative identity. For any integer A into 1 and 1 into A will give you the same number A. Minus 10 into 1 or 1 into minus 10 will give you the same number minus 10. Your answer will not change. Your sign will not change. Same number coming again, that is called identity. Here we are multiplying, so we say multiplicative identity. In the previous case we added, there it is additive identity. Right? So you can say that, for example, it's the same kind of example we can take. Minus 256 into 1 or 1 into minus 256, both will give the same answer. Both will give you the same answer, minus 256. Both will give you the same answer, same identity will reflect back. Multiplicative identity. We discussed additive identity, which is 0. Additive inverse, which is for A minus A. Multiplicative identity, which is 1. In the same way, we have next thing called the multiplicative inverse. The next one we say it is a multiplicative inverse. Okay, before that we have additive inverse. I'm so sorry. This is not additive inverse. Okay, this is a multiplicative inverse. This is a multiplicative inverse. That means we are multiplying. Additive inverse we have already discussed. For A it is minus A. For A it is minus A. Here it is for a multiplicative inverse. For the number A, you need to multiply with some number so that you can get 1 back. In additive, it is 0. In multiplicative, it is 1. So for the number 10, you need to multiply with 1 by 10 to get the value 1. So for the number 10, 1 by 10 is the multiplicative identity inverse. Or you can also say reciprocal. The same thing is also called reciprocal. Whatever it is, the product should be 1. Okay. For number 1 by 10, 10 is the reciprocal, or 10 is the multiplicative inverse. Minus 156 into 1 by minus 1 by 56 will give you 1. The same number should come here. Right? For a number A, 1 by A. A can be positive or negative. But we don't say multiplicative inverse for 0. Do you know why? For the number 0, we need to multiply with 1 by 0 to get the value 1. But 1 by 0, is it a defined value? Is it a defined value? No. For 1 by 0 is not a defined value. For multiplicative inverse will not exist for the number 0. Okay, this is very important. Multiplicative inverse will not exist for the number 0. The question is, what is a multiplicative inverse? What is a multiplicative inverse or reciprocal of the number 0? You cannot say the answer, you should say undefined. You should give me the answer as undefined, because you don't have the answer, you don't know which answer to keep there. 1 by 0 is not a defined number, right? So you can say that for multiplicative, for number 0, you cannot find multiplicative inverse, right? For rest of every number, for A, 1 by A. For 1 by A, they are reciprocals, or you can say multiplicative inverse, right? So the next we are going to discuss about, only multiplicative inverse of 1 is integer. Multiplicative inverse of 1 is integer. Why? For the number 2, what is multiplicative inverse? 1 by 2. Is it an integer? This is an integer, but this is not an integer. For minus 2, minus 1 by 2. But is that an integer? No. But only for the number 1, 1 into 1 by 1 will give you 1. 1 by 1 is equal to 1. You can say that it is again an integer. In integers, only multiplicative inverse of 1 is an integer. The rest of all the integers, you will never get an integer back. Okay. And 0, just now we discussed, 0 does not have a multiplicative inverse. 0 does not have a multiplicative inverse, right? So I think all these are clear to you, right? In the next class, we are going to discuss about distributive property of integers. Okay. Just the way we have discussed closure. Next, commutative. Let me once again discuss about these two. Okay, so that for a small recap. Today we have discussed about associative, and then we also discussed about additive inverse, additive identity, multiplicative inverse, multiplicative identity, right? Let me tell you what are closure and commutative just for your reference. Okay, so when we are taking closure property, if you have two numbers A and B, both are being integers. Okay, so we can say that A plus B is also an integer, A minus B is also an integer, A into B is also an integer, A divided by B may or may not be an integer. So closure property is valid for all these except for division. The same way we discussed about commutative property. Do you remember what is commutative? Commutative is again when we have two integers A and B, A plus B and B plus A. Are these two equal? As said, in addition you can add in any way. Okay, order does not matter, right? It's correct. A minus B and B minus A, are these two same? No, these two are not the same. So subtraction is not valid for commutative. A into B and B into A, as these two are equal, again for multiplication it is correct, and A divided by B and B divided by A, both are not the same, again for division commutative is not valid, right? So all this we have discussed, and in the coming class we will also discuss about distributive property. Just let me tell you, okay, distributive property. So on this we are going to cover the next lecture, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, so today we will be discussing about speed. Now we generally have a basic idea of what speed is, yes or no, right? So that's what we will be learning about mathematically and scientifically. Okay, so my name is Shashan Reddy, I'm a graduate from IIT NEET. Let's go into the class. Right now, all of you would have heard the story of a tortoise and a rabbit, yes or no? So what is that? You know the story. I'm not going into the story part. But if I look at this animation here, what can I say? If I only look at the animation here, what can we say? We can clearly say that the rabbit is faster than the tortoise. rabbit is faster than tortoise. Or in other way we can say the tortoise is slower than the rabbit. Anyway, rabbit is faster than tortoise, or the tortoise is slower than the rabbit. So no, right? So you basically have an idea about what faster and what slower are. And faster and slower depend on speed. And in your vehicles also, like it can be a bike, it can be a car, and nowadays some bicycles also come with some devices which shows the speed. It's called as speedometer. Right, so there also we know about speed. Yes, so we'll be discussing about that. Okay, good. Look at this. There are two devices in a vehicle which are more important for us as of now. One is the odometer. Not odomus, odometer. What does odometer do? Odometer shows us the distance traveled in kilometers, the total distance traveled. Right, can you see that here everyone? This is the one that I am talking about. This is the one that I am talking about, right? You might have seen it many times. Right, so this shows the total distance in kilometers. So if I look at this, this has traveled 98,095 kilometers. Throughout its lifetime, the vehicle has traveled 98,095 kilometers. Okay, and what is that called as? It is called as odometer. It shows us the total distance traveled. Now, how can you use an odometer to travel, to estimate or to measure the distance of a trip? Yeah, it's very simple. At the beginning, let's say it is showing 1025 as a reading. Beginning of trip. Beginning of trip, it is showing 1025. Now at the end, the odometer, let's say, it is showing 1125. This is the end of the trip. So what is the distance of the complete trip? The distance that the vehicle has traveled. For that, you just subtract them, yes or no? So how much will you get? If I subtract these two, I'll get 100 kilometers. So the complete trip was for how much distance? Was for 100 kilometers. Is that clear? So using an odometer, using the readings in the odometer, we can also measure the distance traveled by the vehicle for a trip. And what does odometer show us? Odometer shows us the distance traveled in kilometers by the vehicle throughout its lifetime. Clear? Good. Then we have something called as speedometer. What does speedometer show? The speedometer shows us the speed directly. You can see this pointer is at where? It's at between 40 to 60, then you have 50, 55. So here it is showing the speed how much? 55 kilometer per hour. Generally the units are kilometer per hour here and miles per hour. It can be anything. So here it is showing miles per hour. So how do I get this? Is 40. This will be 45. This will be 50. This will be 55. That is showing 55 miles per hour. In terms of kilometer, it is between 80 and 100. So around 90 kilometer per hour. Now this could be in other foreign countries. In India, we mostly use what? We mostly use kilometer per hour as the main reading. And what is the device called as? It is called as speedometer. So it shows us the speed of vehicle. In India, it is usually in kilometer per hour. In foreign countries, US and all, they might use miles per hour. But in India, we use kilometer per hour. Clear? Good. So, a very simple question to all of you. What is that? The question is this. Look at the speedometers of two vehicles. You can think of one as two different cars. Okay. So, look at the speedometers of the two vehicles shown here and decide which vehicle is slower. And decide which vehicle is slower. Which one? If I call this as A, If I call this as B, which vehicle is slower, A or B? Yeah, everyone. Vehicle A is showing us how much speed? It is showing 60 kilometer per hour. And what is vehicle B showing? It is showing 80. Let's just take it as kilometer per hour to avoid confusion. So 80 kilometer per hour, 60 kilometer per hour. Then obviously we can say that which is slower, 60 kilometer per hour is the slower vehicle. Clear? Understood? Good. Let's continue. So we already have a basic idea of what speed is. In fact, when we say 60 kilometer per hour, what does that mean? It implies that the object travels 60 kilometers in 1 hour. 60 kilometer per hour will mean it travels 60 kilometer in 1 hour. If I take it as 80 kilometer per hour, what does that mean? It means 80 kilometer in 1 hour. Right? So, using this, what is 60 kilometer here? Distance. What is 1 hour here? Time. Yes or no? 80 kilometer distance, 1 hour is time. Right? So, mathematically, we have a formula for speed. What is the formula? Speed is equal to distance divided by time. Speed is equal to distance divided by time, or we can say speed is the unit. I mean the definition. From the formula itself we get the definition. Speed is distance traveled per unit time. If I say 60 kilometer per hour, so 60 kilometer is distance traveled, 1 hour is the unit time. Unit will mean 1. Unit will mean 1. Clear? So what is the formula for speed? Distance by time. So how you define it? You define it as distance traveled per unit time. Clear? Now what is the SI unit of speed? Look at this. When we say speed is equal to distance by time, what is the SI unit of distance? What is the SI unit of distance? Distance is nothing but length, right? So for distance or for length, the SI unit is meter. What is the SI unit? The SI unit is meter. Good. And for time it is second. So what is that going to be? It is meter per second. So the SI unit is what? Meter divided by second. How do you spell it as? You spell it as meter per second. It is not kilometer per hour, it is meter per second. That is a standard unit. The SI unit of speed is what? Meter per second. Clear? Good. Then we'll go into this. Now sir, mostly we come across speed in terms of kilometer per hour. But you are saying that the SI unit is meter per second. So what is the relation between kilometer per hour and meter per second? Let me show that to you. When I say 1 kilometer per hour, it is nothing but 1 kilometer divided by 1 hour. What is 1 kilometer per hour? It is nothing but 1 kilometer divided by 1 hour. Now, what is 1 kilometer equal to? 1 kilometer is 1000 meters. What is 1 hour equal to? 1 hour is 60 minutes. But again, the same 1 hour is also equal to 3600 seconds. Yes or no, everyone? Now you might already know about this. 1 hour is equal to 60 minutes. Now I can write this as 60 into 1 minute. What is 1 minute equal to? And before that, look at this. 60 into 1 is 60. So that's why 60 minutes can be written as 60 into 1 minute. But we know that 1 minute is equal to 60 seconds. So 60 into 60, 6 into 6, 36, 2 zeros. So 1 hour is equal to 3600 seconds. So if I do the calculation, 2 zeros cancel. What is remaining? 10 by 36. The units are meter per second. Then again, can I cancel it? 2 5s are 10. 2 18s are 36. So what is remaining? 5 by 18 meter per second. That means 1 kilometer per hour is equal to 5 by 18 meter per second. Is that clear? Good. So that's what we are talking about. It's nothing but 1 kilometer per hour is equal to 5 by 18 meter per second. Very important. We'll use it. So let's go into this example here. Let's go into this example. The speed of a bus is 72 kilometer per hour, whereas the speed of a car is 12.5 meter per second. Which vehicle moves faster? Which vehicle moves faster? Now, if I look at the number, 72 is more than 12.5. Only when I look at the number. But when you look carefully at the unit, here the speed is kilometer per hour, here the speed is meter per second. So we cannot directly compare them. So what we will do is, I'll take this speed. What is speed given as 72 kilometer per hour? I will convert kilometer per hour into meter per second. And then we can compare the two speeds. Clear? How? Look at this. This can be written as 72 into 1 kilometer per hour. 72 into 1 is equal to 72. Then, what is 1 kilometer per hour equal to 5 by 18 meter per second? 1 kilometer per hour is equal to how much? We know that. 1 kilometer per hour is equal to 5 by 18 meter per second. Yes? Good. Then, when we do the calculation, look at this. 18 into 4. 8 4s are 32. 3 carry. 4 into 1, 4. 4 plus 3 is 7. 72. Yes or no? That means if I do the cancellation, 18 4s are 72. So what is remaining? 4 into 5 meter per second. What is 4 into 5? 20 meter per second. So now if we compare the speeds, what is given here? 72 kilometer per hour, which we got as 20 meter per second. That is speed of one vehicle. The other vehicle is 12.5 meter per second. For the bus, it is 20 meter per second. For the car, it is 12.5 meter per second. So you see these are in the same units. So you can compare them. 20 is greater than 12.5. So which is moving faster? The bus is moving faster. What is moving faster? Bus is moving faster. So to compare two speeds, their units should be equal. Clear? Wonderful. Good. So we'll again come back to this. So we learned about speed. What is the formula for speed? Distance by time. So based on this formula, let's solve a problem. Here, in the given case, calculate speed for OA and AB. O to A and A to B. Let's calculate the speed for that. So let's calculate the speed for OA first. Now you can think of this as a scale. It's a number line, but you can think of it as a scale. Okay. So let's take OA first. Now we know that speed is equal to distance by time. So our target is to first find out what? First find out distance. Yes or no? So here for OA, O is here, A is here. So you can see this is the straight line, this is the path. So O to A, what is the path length? What is the length of the path? It's very simple. I need this length of the straight line. So how do you get this? If I use a scale, think of this as a scale. So at one side you have 0 reading, at the other side you have 35 reading. So what will you do? You will say distance is equal to 35 minus 0. You will say it as what? 35 kilometers. And why am I taking kilometers here? Because it is clearly given. 35 kilometers. What is the time given here? Time is given as 35 hours. Clear? Good. So we got all of them. That's wonderful. Now you have distance, you have time. We have to calculate speed. What is speed equal to? Speed is equal to distance by time. So what is distance here? Distance is 35 kilometers. What is time here? 35 hours. Distance is 35 kilometers. Time is 35 hours. 35, 35. Can you cancel them? 35, 35. Can we cancel? Yes. 35. Ones are 35. So what will remain? 1 will remain. So what is the speed here? The speed is 1 kilometer per hour for OA. So first we find out distance, then we find out time, and then we use the formula speed is equal to distance by time. Simple? Clear? That's for OA. Now you do it for AB. Everyone find out speed for AB. I'll give you some time. So find out speed for AB. A to B. For AB, for A to B, what is the speed going to be? Find out distance, find out time, then speed is equal to distance by time, you will get the answer. So here when we say AB, it is from here to here. So think of this as a scale. So on the scale, one end you have 35 reading, at the other end you have 60 reading. So what will distance be equal to? You subtract them, 60 minus 35, that is equal to 25 kilometers, because kilometers is given. So distance we get it as how much? 60 minus 35. 35, 60, you subtract them, we get distance as how much? 25 kilometers. Then time is given, how much is time given as? 50 hours. Time for AB is given as 50 hours. So if I go into the speed part, what is speed equal to? Speed is equal to distance by time. Speed is equal to distance by time. Distance we got it as 25 kilometers. Time we got it as how much? 50 hours. Then if I do the calculation, see here, 25 ones are 25. 25 into 2 is equal to 50. So what do we have here? We have 1 by 2 kilometer per hour. There you have it, speed. Clear? Understood? Good. So for OA we got the speed as 1 kilometer per hour, and for AB we got the speed as half kilometer per hour. Clear? No issues there? That's good. Now look at this here again, same 1 kilometer per hour and this. Now if I ask a question from O to B, from O to B, that is for the complete motion, what is the speed? What will you tell? Will you tell it as 1 kilometer per hour or will you tell it as half kilometer per hour? I'm asking you for the complete motion O to B. You have two different speeds. So you can't tell it as 1 or you can't tell it as half. You can't tell it as 1 kilometer per hour or you can't tell it as half kilometer per hour. Understood? Then what will we do in this case? For that, we define something called as average speed. What is the formula? Same formula or similar formula. The only thing is we take total distance, we take total time and divide them. It is total distance covered by total time taken. That is what? That is average speed. So average speed is equal to total distance covered by what? Total time taken. Understood? So keeping this in mind, let's go into an example. In fact, the same example, find the average speed for OB. I told you, right, for the complete motion. Yes. So here for the complete motion from O to B, what is the distance from O to B? From O to A, we already got it. From O to A, it is 35 kilometers. From A to B, it is 25 kilometers. The total distance will be how much? 35 plus 25, that is equal to 60 kilometers. This is what total distance traveled. Then if I go with total time, look at that, what will total time be? 35 plus 50. You have to add the time, 35 plus 50, which is how much? Which is 585, which is 85 hours. Look at this. 50 plus 35, 0 plus 5, 5, 5 plus 3, 85. Clear? So we got total distance, we got total time, we got both of them. Yes. Then if I need average speed, what will you do? You divide both of them. Average speed is total distance by total time. What was total distance? 60 kilometers. What is total time? 85 hours. So it is 60 kilometers upon 85 hours. 60 kilometers upon 85 hours. Then if I do the calculation, how? Look at this. 12 into 5. What is 12 into 5 equal to? 5 to 10, 5, 1, 5, 5 plus 1, 6. 60. Then if I look at 85, 17 into 5. What is 17 into 5? 7, 5, 35, 3 carry, 5, 1, 5, 5 plus 3, 85. That means 5 into 12 is equal to 60. So if I cancel with 5, 5 12s are 60, 5 17s are 85. So you have 12 and 17 remaining. So it is 12 by 17. Units are kilometer per hour. That is the average speed. Clear? So for average speed, it's a very simple formula, total distance by total time. That's it. If you stick to the formula, you will get the answer. So speed is equal to distance by time. Average speed is equal to total distance by total time. Good? Okay. Let's go into another question here. A very simple question. An object travels 16 meter in 4 seconds and another 16 meter in 2 seconds. What is the average speed of the object? I'll give you 1 minute of time. Please solve it. Yeah, everyone, please solve it. Object travels 16 meter in 4 seconds and another 16 meter in 2 seconds. What is the average speed of the object? Yeah, please solve it. Stick to the formula, everyone. Find out total distance, find out total time, divide total distance with total time, you will get the average speed of the object. The time is almost up and the time is up. So let us solve it. Here total distance. Now first of all, before we go into that, let's try understanding what's happening here. An object is starting from here, let's say start point. An object travels 16 meter, let's say this is 16 meter, how much time? 4 seconds. And another 16 meter in how much time? 2 seconds. So here, what is the total distance then? The total distance is equal to 16 plus 16. That is how much? 32 meters. 16 plus 16, how much? 32 meters. What about total time then? Total time is 4 plus 2. And 4 plus 2 is equal to 6 seconds. Understood? So you have total distance, you have total time. Then after that, it's a very simple formula. Average speed is equal to total distance by total time. Total distance by total time. So if I keep this in mind, what is total distance? 32 meters. What is total time? 6 seconds. So 32 meter upon 6 seconds. That's it. You need not worry about anything else. And 2 into 2 16s are 32. 2 3s are 6. So what is that? It is 16 by 3. 16 by 3 meter per second. That is the answer. That's it. You got the answer. So get total distance, get total time, divide them, we get average speed. Is that clear? Good. Now we have a formula. See here. We had a formula for speed as distance by time. But again, if I need a formula for distance, do you know what it is going to be? You take time to that side, it becomes multiplication. Distance will be equal to speed into time. That is the formula. So if you have speed, if you have time, you will get distance. I'll give a simple example for you. Let's say speed is equal to 60 kilometer per hour and time is equal to 2 hours. How do you get the distance? Distance traveled, you go with 60 into 2, you will tell it as 120 kilometers. Yes or no? Because 60 kilometer per hour will mean 60 kilometer in 1 hour. If you need that in 2 hours, you multiply with 2. 60 into 2 becomes 120 kilometer, 1 into 2 becomes 2 hours. That's it. End of story. Clear? Good? Wonderful. Now, so we'll use this formula. What is that? Distance is equal to speed into time. Let's go to a simple example. Here, find the distance traveled by a car traveling at a constant speed of 50 kilometer per hour in 2 hours. What is given here? What is given? Given information is speed is equal to 50 kilometer per hour. Time is how much? Time is equal to 2 hours. And find out the distance traveled. How will you do it? Distance is equal to speed into time. So what is speed here? Speed is 50. What is time here? 2. We'll get it as 100 kilometer. Option D. In fact, you need not be worried about the units, because here, when I write 50 kilometer per hour into 2 hours, speed into time, here units, see, hours cancel. So what is remaining? Only kilometer is remaining. So we will write 100 kilometers. We'll write how much? 100 kilometers. Clear? Now similarly, we also have a formula for time. What is time equal to? Distance by speed. So you have a formula for speed, you have a formula for distance, you have a formula for time. Is that clear? Okay. Now there is one simple question. I'll leave this as an assignment to you. Here you have to find out time, use the formula, you will get the time in this case. Okay. So that's it, everyone. So we learned about speed, we learned about distance, we learned about time also in this class. Also we learned about average speed. So please do practice. Practice is very important. Okay. So thank you. Thanks a lot.